ingots. They are metal bars that are made for further processing. In metal melting, you want a clean and raw source of metal that you can easily melt. That's where ingots come in. You can buy them or you can make your own. In this video, we're gonna make custom iron ingot molds by melting some broken iron weight plates in an ordinary microwave oven. And towards the end of the video, I will show you how you can make custom ingots without using these iron ingot molds and without using a microwave kiln.
So I started by printing a mold in translucent PLA.
This is not my first time making these ingot molds. I made one 3 months ago and I shared that video on Patreon. In the Patreon video, I used a square mold and then I had to shave it in order to be able to fit it inside of the microwave kiln. As you know, I have a new microwave and I made another much bigger microwave kiln, so now we can use bigger molds and no more shaving, except for face and bone. Let's see how much sand we'll need. 2 kilograms. So for 2 kilograms I'll need 200 grams of sodium silicate if I use 10%.
And then I froze it.
Oh no, I lost a piece. This is not very frozen. This is only... oh, it's quite soft. Be careful. I only froze it for an hour, which is not a lot. Enough, but you have to be careful. 8 seconds on. I'll go for 2 minutes off.
8 seconds because I'm trying to match the defrost setting.
Okay, we'll run it for maybe an hour and then I'll go to 12 seconds on. It's been almost 50 minutes of microwaving. Let's see. Okay, yeah, this is feeling good. This is feeling good. So let me change the cycle to, what was it now? What did I say? 12 seconds. So that's it. That was 12 seconds of microwaving, or more or less equal to 500 watts. More or less. So it's quite hot. I can touch it. There is still some moisture in it. I can feel it, but that's fine. That's temperature 70 degrees Celsius. Almost. So now I'm gonna transfer it to the microwave kiln and we'll burn it out. So now the cycle is 30 seconds on and 2 minutes off.
After approximately 2.5 hours, the plastic was already burning. You can see it has turned yellow. It's fine, but ideally I prefer to remove it before it starts to burn for various reasons. Less smoke and also, well, you can reuse it if you want to.
It's the next morning. Let's melt some iron. Here I have 350 grams of cast iron, broken weight plates. Okay, let's preheat this crucible and let's do some melting.
With the time you learn how bright the crucible should be for the iron to be molten. If it's not bright enough, I just don't open the chamber. I'll clean it up later. Let's make another mold. This one is a different shape. This time I removed the molten plastic before it turned yellow. That way I can reuse it and make whatever I want.
Most of the times when I pour iron in these sand molds, the molds crack. But it doesn't really bother me because usually it happens after the iron has solidified, because it solidifies very fast. I don't pour it that hot, so it doesn't really matter. Sure, there have been times when I poured my iron a little bit hotter or the molds cracked earlier, but usually it works pretty good. And also my molds are usually warm, not hot. That's because I might burn them out today and cast it tomorrow, and I just can't be bothered to reheat them. Because it works pretty good, I haven't had a need to reinforce my molds in any way. That said, there are some upcoming projects where I'll need my molds a little bit stronger, so I have been experimenting. I didn't want to go over the top and reinforce my molds with, I don't know, fiberglass or add things to the sand. I just wanted something simple, so you have seen me using the aluminum foil, which does help, but it's not ideal. I also have been experimenting with stainless steel zip ties, though I find that you can't really tighten them very good, even if you use the tool. And one more thing I wanted to try was these cable ties. Clamp set, not cable tie. Whatever. I was going to use 3 of these clamps, but I didn't realize that the teeth don't go all the way round. So I put on one, and the next 2 I wasn't able to tighten because there were no teeth. So yeah, I guess we'll try it out some other time.
It can take some elbow grease to get out all that sand. I'm not gonna cut off the button because it's an extension of the handle, so we just can keep it as it is.
If you have been watching this channel for a while, you'll know that I don't like to spend too much time on sanding. And these are no exception. They could have been sanded better. For example, the corners here are not as sharp, and the molds could have been a little bit smoother, but as I always say, it's good enough for me. There are different reasons why people make ingots. For some it's a hobby. They collect scrap metal, they melt it down and make ingots. And then there are people like myself who make ingots because they will use them in their future projects. Let's take this aluminum lamp as an example. It's much easier for me to cut it, melt it, and make ingots in advance that can be used later than deal with all that stuff on a day when I'll try to cast something, because it takes time. Speaking about time, it's time for us to part. Hey, don't worry, chin up. There is a life after the lamp, I promise. We had good times. You showed me how to live.
You say slow down. I don't like to move too fast. It drowns the truth with
Alright, let's melt it.
things that are not real, and
Unfortunately, I only have this size crucible. I don't have taller ones at the moment. I had one, but eventually it got damaged, and I haven't made any more crucibles because I'm working on a version 3 crucible molds. I already tried them out with this size crucible and they're a little bit better, so I need to try it out with a bigger molds as well, but we'll get to that. So I did go outside and I flattened some of these pieces so I could fit more in the crucible. Change of plan. I'm not gonna keep melting the lamp. I already did melt most of it and I'm only left with these smaller pieces, but because they're covered with paint, it's just too smelly, so I can't continue melting it. That said, I do have other metal that we can melt, so we're good. Now I did hear some cracking noise and I hope it's not the mold that cracked. Normally I use a blowtorch to heat up the mold before pouring the aluminum, but this time I didn't. I only heated it up on my induction cooktop because I wanted to see if that's enough. Was that a mistake? We shall find out. It could have been the tray that made that cracking noise because it has done it before many times. It just moves. I don't see anything. I think we're good. Yeah, I think we're good. Oh, that's not the prettiest ingot.
This one came out beautiful. That was aluminum. Let's try brass.
I should have melted more brass. Usually when you pour more metal in your ingot molds, that's when your ingots come out better looking. But yeah, brass is something that I don't really melt and work with. I just don't like it. In other words, I don't touch brass unless it's missing bromine.
Let's try copper. I had to give it a wash.
I have said it before and I'll say it again. This has been one of the most useful items I have ever made. I wish I had made it earlier. So how much these ingots weigh? Well, the biggest one weighs almost 140 grams, 139 grams. And let's see, this smaller ingot, 77. So almost half of that. And I want them small because I want to be able to fit them inside of this crucible. Whether it's one or a few, depends how much metal you would pour. But yeah, couldn't be happier. And if you want to make your own ingot molds, you'll find files on my Patreon page. But what if you don't have capabilities of melting iron, or you already have an ingot mold, but you would love to make a few custom ingots, maybe with some text on them? Well, there are ways you can do it. And the cool thing, you don't even need a kiln or do any burnout. I have spoke about it in the printwave metal casting video. So what do? We just print the ingot, and the way I normally do it, I make a shell out of the ingot. So the walls all the way around, it's 0.8 millimeters. And the bottom of the ingot is 0.2 millimeters. So you print it with internal supports. Before we continue, I just wanted to take a moment and thank all the Patreon and YouTube supporters. With your support, we can keep doing what we're doing. As the saying goes, microwaves don't grow on trees. I also want to give a shout out to all the Crucible Club supporters. Thank you. And this month we had our first insulin shot supporter, which is a way how you can contribute to the channel by giving once and then just cancel your membership. Now I'm not gonna try to pronounce the username because I will butcher it. But yes, thank you very much. The person also has a webpage if you want to check it out. And I thought, why not put the username onto the ingot?
I printed the text on the side and then I just buttered it with some Vaseline, just so it would release easier. I also printed a box which is also 0.8 millimeters thick, just to save on plastic, and I used some electrical tape just in case if the print comes loose and the plaster could leak. Obviously you don't have to pour your plaster on top of the 3D printer, you can remove the build plate, but I do it because I can run a G-code that can help to shake out the bubbles. Though I do have different G-codes, and this one was a little bit too slow, but it does help. Once the plaster has set, we remove the mold from the build plate. I don't know how well it works with other 3D printers or other build plates, but with Prusa build plates it works like a dream. Then we open the bottom and remove the supports. It's quite easy to cut because it's only 0.2 millimeters thick. Then we put it inside of a plastic bag and we microwave it. Just don't be too aggressive with microwaving, it could ruin the mold. The plastic will soften and you'll be able to remove it. I start by peeling the side where the text is. And then you can just remove the rest. This method is great because you can do things that you wouldn't be able to do with traditional sandcasting. Unfortunately, even though I shake the mold, I still got an air bubble. Oh well.
And then we just bake it in an air fryer. I usually start at a lower temperature and then I gradually increase the temperature and bake it at the maximum temperature my air fryer can provide, which in my case is 230 degrees Celsius. Now, in theory, to get rid of all the chemically bound water that plaster can contain, you would need to use a kiln. But in practice I find as long as you bake your molds for many hours, you can get rid of most of the moisture. In other words, the mold will not be dangerous anymore and you'll be able to pour metal in it. Just remember, smaller molds need less time and bigger ones will need more time, 10, 12 hours or even more, so you need to do some experimentation. One thing you don't want to do is pour molten metal in wet molds. I put together a little demonstration. I made a few plaster of Paris molds and then I just air dried them for a few days. So they were still very wet, and this is what happened. It's been 5 hours of baking the mold in an air fryer. Is that enough? Well, I hope so. Normally I would bake it maybe a little bit longer, more like 7 hours, but I'm short on time. I want to finish this video today so I can publish it tomorrow. So let's just do it. But what metal should we melt? Well, I thought because this mold is so simple, let's continue on that trajectory and do simple metal melting. Something that doesn't require crucibles. Let's melt zinc. So this is the way it came out. There was an air bubble somewhere, so it's not perfect. There's also a little imperfection here, but other than that, it's looking pretty good. You can do the same thing with sand molds. You can pull out the 3D prints from the sand, though the text is a little bit trickier, but there are ways. I was going to include it in this video, but at the end, it was just too much, so we'll keep it for some other time. Subscribe if you haven't, and I'll see you next time.